สวัสดีครับสวัสดี to my international student. Today I'm going to demonstrate you how to determine the absolute maximum shear force and the absolute maximum bending moment that's going to occur on the 30-meter long simply supported girder and is also subjected to the moving load. The moving load on this problem is kind of big one. It has four of the point load acting on the wheel of this vehicle, and it's going to pass to the 30-meter girder of the bridge. And when we start to find the maximum shear force, it's going to be the absolute maximum shear force. You have studied about determine the maximum shear force before, but for the absolute maximum shear force, everybody know that this is going to occur at what? At the support, right? Because most of the force, shear force, for example, for a simple beam like this, subjected to the force at the middle of the beam, and you may see under this force P, we will have this reaction of P over 2. And if you draw the shear diagram of this beam, you may see that the maximum shear force, okay, for this one occur at the support, okay. And if you change this one to subjected to a uniformly distributed load, okay, for W, you may see that this one gonna have what? Gonna have WL over 2, and this one also W span over 2, and the maximum shear force will occur at the support again. So most of the time maximum shear force occur at the support, okay. And for this kind of beam, let me move the load to this size. If you guys compute, you find this reaction will larger than this reaction, and then the shear force gonna be large on this side and smaller on this side. Anyway, these three cases show you that the maximum shear force is occur at the support of the beams, okay. Mostly is occur at the support of the beam, and the absolute maximum also is may occur at the support A, and is also may occur at the support B for the absolute maximum shear force. And most of the time, the absolute maximum shear force on the support will be equal, okay. So if you like to determine this, you got to move the vehicle passing the bridge, and this time let me consider to find the absolute maximum shear force at the support B, okay. And by doing this, let me trying to draw the girder first, and what we have is 30-meter girder. And if you measure this, you may see okay, you may take this one for 10 centimeter if you like, okay. And you will put the load into this portion, or if you like, you may put on the A. It's no matter, it's going to get the same result, but I prefer to put this example to the support B, okay. The step of determining the absolute maximum shear force, okay, this is the A. We're going to determine the V absolute max, and we know that the maximum shear force occur at the support of the beam, and we will draw the influence line diagram of this time we interested at B. Okay, let me is at B, and you make try to work for the A. Okay, let's see. Terms of B sub y, and by doing this, let me take this for 10 centimeter, and let me put this one to draw the influence line of B sub y. So the A going to be the same, and since B is the pin, okay, let me release or eliminate resistance to the B sub y. However, the resistance to the B sub x still there, and then we push this beam up by the reaction B sub y for 1 unit. Okay, it's going to be up for 1 unit, and then what we have is the shape of the girder, which is the influence line diagram of B sub y. And you may see we have the point load. When we determine the reaction of the shear at B, we will multiply the magnitude of this point load with the coordinate of the beam. So the next step, we will put the loading, the moving load, the loading pattern to the girder. So what the loading pattern that we can move, since the beam have the tuck like this, and since the influence line of B sub y opposite, so the maximum should occur when the load all apply to the beam. Okay, let me start. First, we just say this car going to Kolat. Okay, and then we put another way the vehicle going to Kolat. Okay, and the other way the vehicle go to Bangkok. And by doing that, we will have 2 cases. Okay, let me put the first one like this, and we put what? We put the 45 kilonewton here. When you put the 45 kilonewton here, this is gonna be 45, and the car is what? 4 meter, 3 meter, 4 meter. What we have now that I said is 10 centimeter for 30 meters. So the scale that we use, the scale is going to be 3 meter per 1 centimeter. So 4 meter going to be like about 1.3 centimeter. 1, 2, and 3. Okay, that is going to be 160, and another 3 meter. That is going to be 1 centimeter. That is the 90. That is going to 90, and it's going to be 4 meter. That is about 13 centimeter. So the load gonna be, the first case is like this, is 160 kilonewton, and this is going to be 90 kilonewton, and this one also going to be 90 kilonewton. Okay, that's me consider the first case of this. And in the opposite direction, okay, this time the 45 kilonewton will be moved into this direction. Let me put this one to the beam again, and okay, this time this is the pin, and this is still the roller, and this time the 45 kilonewton is going to be on this direction. So we should start by putting the 90 here. Okay, so this time we put the 90 kilonewton here, and then it's going to be 1.34 meter. That is going to be like 1.3. But it's going to be the same. This is going to be 4 meter and it's 90 kilonewton. It's the reverse of that. And then 3 meter, that is going to take for this. It's going to be alignment with the previous one. That is going to be 90. This is 160. This is 160 kilonewton. And the last one is going to be this one. And it's only 45 kilonewton. So this one move in the opposite direction of the first one. Okay. And there are some cases that we need to put, 3 of the wheel loads onto the beam also to consider to be the other step. And let us check, okay, whether the 3 load that put on the girder gonna produce the maximum shear force or not. Okay, just Thai is 2 different cases, but 2 wheel loads won't for sure, but the 3 and the 4 maybe, okay. And we have this time, let's take this 45 kilonewton out. Okay, let's take that 45 kilonewton out and put the 160 kilonewton here. Let's put the 160 kilonewton here. So let me put this one here, 160 kilonewton. And then the 45 kilonewton gonna move out to this position. Okay, that is going to be 45 kilonewton. And then we have 3 meter. 3 meter is that's going to be 90 kilonewton. And we have 4. Okay, that is going to be about this. K. We have this one for 90 kilonewton. And then this is 4 meter. And this is 3 meter. Let us check like this. This is going to be in the different location. Okay, this one going to be at the same point, and this one going to be at the same point. Okay, and another interesting thing, in case that are supposed to occur when this one, okay, we move the 90 here, and the other gonna move in accordance with also. Okay, by doing this, we consider 4 cases of them. This one, the 90 gonna move. This 90 is going to be here. Just put this one as the 90 kilonewton. And this 4 meter, just take away from here. And that is going to be 90 kilonewton. Let's move out into this way. Okay, and sorry, and this case, what we should have is what? Should have is what? This one move here, and this one is 4 meter. So you have 3 meter between this one and this one of 160. This is 3 meter, and this one is 160 kilonewton. Okay, and the last one is gonna move for 4 meter, so it's going to be 45 here. That is going to be 45 kilonewton here. So this one going to be like this. Okay. Okay. We have 4 cases, and then what we should do is next step. Compute the maximum shear force for each case. Okay, for each case we have total of 4 cases. So case 1 is here. Let me put it in the red. Case 1. In the case 1, what we have is the 45 gonna time 1. Okay, and 160 gonna time this, okay, and then 90 gonna time this coordinate, and the 90, this 90 gonna time this coordinate. So let's compute the coordinate of this. I set this one to be the b. This is going to be y sub b. This is y sub a. Okay, y sub a is okay, is equal to 1. Y sub b. This is c. This is y sub c. This is d. This is y sub d. And this is e. This is y sub e. And by similar triangle. Okay, by using similar triangle. We have what? We have 1 divided by the total length of the beam of 30 meters. So 1 divided by 30. And it's going to be equal to, this is going to be projection, this is going to be 3 meters. Okay, this is 3 meters. And it's going to be what? Y sub b divided by 27. Y sub b divided by 27. And then the difference between this one and this one is 4 and 1. So it's only 1 meter here. So y sub c divided by, this is 4. Y sub c divided by 30. And then minus 4 is going to be 26. Okay, and then between this and this is going to be 3 meters. Okay, that is going to be 3 meters. So this is 3, 1, 3. It's going to be 7. So the distance here between my finger and the tips of the pencil is going to be 23, right? That is going to be y sub d divided by 23. And the last one we have, this is 4 meters. So this one plus this one plus this one and plus this one gonna be 11 meters, right? So the last portion over here is going to be 30 minus 11 is going to be 19. So this is going to be y sub e divided by 19. Okay, by doing this, you can compute y sub b equal to 27 divided by 30. Okay, this is going to be 27 divided by 30. And the next one is going to be 26 times here, and it's going to be 26 divided by 30. And the also one is going to be this. This is going to be 23 divided by 30. And the last one going to be 19. It's going to be 19 divided by 30. Okay. Okay. So we are ready to compute the maximum shear force for each case. So the case one we have for the case one. Let me compute. Let's say this is By, and you may know the By is equal to the maximum shear force at B. The maximum shear force at B. Let's say at B for each case. So this B sub y is going to be 45 times 1. 45 times 1. And 160 plus 160 times 26 over 30, right? 30. And plus this is 90 times this one, plus 90 times 23 over 30. And the last one, plus 90 times 19 divided by 30. That is going to be the case one. And then you put everything into your calculator and do it slowly. You may get this force to be 309.7. You may pause the clips, okay, and try to compute, put acting in your calculator. So the second one, we have case 2. The case 2, the square is here. So the b sub y gonna equal to what? 90 times 1. So we got 90 times 1. And then we got another 90, but this time is 4 meters. So it's gonna time this one. It's gonna be plus 90 times 26 over 30. And then we move another 3 meters. So this coordinate gonna time 160 plus 160 times 23 over 30. And this one is 45 and plus 45 times what? 19 divided by 30. And then you get for the second case of maximum shear force at B. Okay, stop the clips if you like and put the number into your calculator. You may get this one a little bit higher than the case one is 319.2. Okay, and then we have this one, the third, case 3. We have case 3. And what we see the case 3, in the case 3, the 45 out of the inference line diagram of B sub y. So it's going to be 45 times 0. And then we have what? 160 times 1 plus 160 times 1. And this one is 3 meters. So the 90 gonna time 27 divided by 30 plus 90 times this one 27 over 30. Okay, and another 90 kilonewton, that is 7 meters. So it's time this plus 90 times 23 over 30. And then you get for the third case. Okay, and you put this one into kilonewton. And if you do it slowly, you may get this one 310.0. It's larger than the first case, but it's less than the second case. And then we have the last one for this case. Okay, we have what? We have case 4. This one. This one is gonna be case 4. On our case 4, our b sub y gonna equal to this 90 times 0. 90 times 0. And this 90 gonna time 1. Okay, this is 90 plus another 90 times 1. And this is 3 meters. And 160 times this one plus 160 times 27 divided by 30, and plus the last one 45 plus 45, and this one is 7 meters, so it's going to be 23 over 30. And then you get this going to be 268.5. So the last one 268.5 is going to be the smallest one. Thus we have what? Thus therefore we have V absolute maximum equal to 319.2 kilonewton. That is the absolute maximum. That means it's a maximum of the maximum, right? So you got this for max is occur at B. And if you like, you may try to do the same thing at the support at A. Okay, I think you can do that, right? Okay, we finish the first part, and then the second part, let's say the B, we are going to determine determine what this time? We will determine the M absolute max. And you may understand that for the simple beam, most of the time, the maximum moment occur near the midspan of the beam. For this one, the maximum going to be have the shape like this, and this one going to be a max. See, it's going to occur near the center of the beam. And also for this one, sure, you guys can draw this. Again, the maximum moment gonna occur near the center. Okay, but for this one, since the force just move anyway, the maximum going to be in this portion. So you can see that by considering the simple beam, the maximum moment most of the time occur at the area near center of the beam. Maximum bending moment is usually occur in the area near the midspan of the girder. Okay, so by this concept, and if you may recall from the lecture, we will put this car in the center or the midspan of the beam. But before we can put that, we're gonna find first the resultant force, the F sub R of this series of moving loading. And we also need to determine the what's so called the location of that F sub R. Okay, and based upon that, let me consider this series of loading and trying to expand them a little bit more. So it's going to be 433, and that's it's going to be 1.3. Okay, and then 1, and then another 1.3. Okay, that's it's going to be 1.3 and 1, and that is 4 meter. Let's see, it's going to be 4 meter and 3 meter and also 4 meter. And then you get the force acting on this one of 45 kilonewton, and over here is 160. This is going to be 160 kilonewton, and the other going to be 90 kilonewton, and this one going to be 90 kilonewton. So the first step that we may have, we're gonna find or compute F sub R. Okay, this is gonna be what? The F sub R is gonna be the summation of these forces of 90 plus 90, and then plus 160, and then plus 45. That is going to be what? Put it into the calculator. That is going to be 385 kilonewton. That's going to be the first. Okay, and then the second one, we find the location of F sub R, find X bar. So what is going to be, and I think it's going to be somewhere between here, because it's 180 here, it's going to be 205 here, so it's going to be very close a little bit to the 160 kilonewton. Okay, let me put this one into this position. It's going to be half, right? This is going to be, this is 205. This is, okay. Let's put this one about here. Okay. And it's going to be the F sub R. And by putting this, you're gonna set up the reference line. If you say this is gonna be the reference line, you may determine the X bar, okay, by taking the moment about this reference line, okay, by using the concept of equivalent, by using the concept of equivalent moment, okay. And then what we have is going to be take the moment about this point, F sub R times X bar. So we have 385 times X bar, okay. And this moment rotate in this clockwise direction, so it's gonna equal to this, going to produce for the equivalent moment, it's going to rotate at the same direction. 160 times 3, it's going to rotate this way, so 160 times 3, and 45 gonna rotate this times 7 plus 45, and then times 7. But we have this one going to rotate in opposite direction, minus 90 and times 4. Then this 90 produce no equivalent moment, but this 90 going to produce the minus 1. So we will get the X bar. We will get X bar. This X bar going to be what? 1 point. Put it into your calculator. Pause the video. And it will be 1.1298. Okay. So, and then the concept of finding the absolute maximum moment, we going to put this loading to the area, okay, of the midspan of the beam. So first one, we gonna divide this X bar into 2 parts. Let me divide this one into 2 parts, and we will put this into the midspan of the beam. Let me put this one in, okay, let's say in this area. Actually, this one is no good. We may take this one out. Sorry for this. The design of the examination is not that compatible what I'm working here, okay. When you do this in your examination, try to work incompatible with that. I have the problem because I'm going to record all I'm writing. That's why I have the problem with this line. Okay, let me have this. We have what? We have the beam again. This beam is here. Okay, we put the beam here. This is 10 meter beam. 30 meter beams with 10 centimeter on this, and then we have this as the roller, and we have this as the pin, and the center of the beam is going to be 15 meter and 15 meters, so it's going to be 5 meter, and it's going to be okay. And if you do this, this is going to be half of the length, 15 meter and 15 meter. What we have now is we going to put this half of the x bar. What is going to be half of the x bar? If you divide x bar by a half, the distance here and the distance here gonna be what? X bar divided by 2. So x bar divided by 2 is gonna be equal to what we have, 1.1298 divided by 2. It's going to be 0.56 and 49 meter, and they are going to be equal. Okay, so we put the green over here, right here. Put the green right here, and let me zoom this one more so it's going to be clearer for us to work on this. We put the green here. When you put the green here, what happened is you measure to the left, okay, for 0.5649, you get the 90 kilonewton. So this is when you do the scaling. Scaling what we have is 1 centimeter for 3 meters. So 3 meter is for 1 centimeter. So we have about 0.5649. It's going to be 0.5649 divided by 3. Okay. And time 1. That is about nearly 2 millimeter. So just put this one about nearly 2 millimeter. Okay, the 90 kilonewton gonna be here. This 90 kilonewton of the reference line, 90 kilonewton. And then you move another 4 meter. So that is about 13 millimeter. And then you get another 90 kilonewton. This is 4 meter. And then you move 3 more meter. Okay, you got 160 kilonewton. 160 kilonewton. And if you move 4 meter, that is about 13 millimeter. About. You put this one for the scaling. That is going to be 45 kilonewton. And then this 4 meter. Okay. And you also have the F sub R here. That is going to be 0.5649. So that is going to be by scaling of this, about this. This is going to be your F sub R, okay, of 385 kilonewton. And the distance of this is going to be reflect back here and reflect back there. Okay, and now by the lecture, the absolute maximum moment will occur underneath the wheel load that's closest to the midspan of the beam. So for case one, we will find the M max here. Okay. Third. Loading pattern one. Okay, pattern one. And what we have, we will determine what the beam on just this portion, the maximum moment will occur. Okay, I will write later. Just me put this one first to make it. So we will consider this free body diagram, and to consider this portion of the beam, that means we going to determine the A sub y, and it's going to X here, okay, and the maximum moment gonna occur here under the 90 kilonewton. So this one is 90 kilonewton, and this one also the 90 kilonewton. This is 4 meter, and the length of this is what? This is going to be 15 divided by this. So this one gonna be 15 minus this is 0.5649, and you may have this one for 14.4351. This is 14.4351 meter. So this is going to be the length of our beam segment that we are going to use to determine the M1. This is going to produce the M1 and the shear also here. Okay. Okay, if you guys have this, we just zoom it a little bit out, and then we have the compute area here. The maximum moment will be occurred, okay, at the location under the wheel load that is closest to the mid span of the girder. That is going to be the principle for this one, and we did prove it from the previous example. Okay, so from the free body diagram of the girder A, B. Okay, we just take the moment about here, summation of the moment about, let's say, B equal to 0. So A sub y gonna rotate this way. So this is gonna be plus, and we have the A sub y. Take me here. A sub y gonna time what? Gonna time the 30. So that is going to be 30 A sub y. And then we have choice to compute the moment due to the moving load. Okay, you may use this each of the moment of these 4 loading and about B, or the best way is by using the concept of equivalent moment again, by using the own concept of equivalent of moment. What we have is we may use the F sub r, and then we take the distance of F sub r to the location of B. You understand that, right? By using the concept of equivalent moment. Let me highlight it. You may select to use this, and this is going to be what? Again, this is going to be 15 minus this one. Okay, that is going to be 15 minus same one, 0.5649. That is going to be the same as previous one. That is 14.4351 meter. So that's gonna time 14.4351, and then you will have the A sub y of, put it into your calculator, 185.25. Okay, and this one going to be 185.25 kilonewton. And then you use the what from the free body diagram of the 6 min. The 6 min of the girder. Okay, and then we do the same thing, summation of the moment. This time gonna be this one is positive, equal to 0. Let's say this one is the M1. This is for the first case, okay, for the loading pattern 1. And what we have is what the M1 gonna rotate this one, and then this one gonna rotate with the M1. So we plus 90 and time 4. However, this one gonna be in the opposite direction, so that is 185.25 gonna be equal to 185.25, and it's gonna time what? It's gonna time this distance. Okay, it's gonna time 14.4351. And now you get the first case for the M1 equal to 2315.1 kilonewton meter. So this is going to be the maximum for the first one. Okay, and next we going to put the same thing, this one, but we have another case that we going to find the center of this portion and push it into the into the mid span of the beam. Okay, let me do again for this second case. Let us put this one. Okay, for the second one now, let me zoom it again. Let me zoom this one again, and we have the same thing, but we will use the different. This is 90 location to put to the mid span of the beam. Okay, this is gonna be 160 kilonewton, and this is gonna be 45 kilonewton. But the same thing, we has this F sub R, and the location X bar here we have is for 1.121298 meter. So the length of this is going to be 3. This is going to be 3 minus 1.1298, and then you're going to get this one for 1.8702 meter. And now we're going to divide this into half, and we will put this one into the center of the beam, and we will find the maximum moment for the second case. Okay, let me do the same thing. We will put this into the beam. We draw the beam here now. This is going to be 30 meter beams again, and we're going to divide this one by half. 1, 2, 3, 4, and 5. This is going to be half of the beam, and this is going to be 15 meter and 15 meter. So this is going to be pin and roller. Okay, and this is going to be 15 meter, and this also be 15 meter, and we gonna put this loading onto our mid span. So put this bowl into this one, and you may see that when we divide this into this portion, this is going to be what? This is going to be 1.8702 divided by 2, and then we get this for 0.9351 0.9351 meter. Okay, you do the scaling again. 3 meter for 10 millimeter and 0.9351, you may get the 0.9351 times 10 divided by 3. Okay, you may guess that's about 3 millimeter. Okay, so what we have is drawing here about 3 millimeter, you get 160 kilonewton, and this one for about 3 millimeter, you get F sub R. So this is going to be 1, 2, and 3 millimeter. 1, 2, and 3 millimeter. So you get this one for 160 kilonewton. Okay, this is going to be 160 kilonewton. And this one is here. You put this one for 4 meter. You put this one for 4 meter is equivalent to about 13 millimeter. You get this one for 45 kilonewton. And then you take another 3 meter. Take about 1 meter. You get the 90. Okay, you get the 90 kilonewton. And in between this one, you get your F sub R. Okay, this is going to be 385 kilonewton, and the half of this, okay, you may put it back here, 9351 millimeter, and then you got the 90. This is going to be 4 meter. You take this one for 13 millimeter. You get this 90. That is going to be 90 kilonewton. This is 4 meter. This is going to be the second case. And if you observe this one with the previous one, they are not the same, but they are similar. Okay. And this time, by using the same concept as before, the maximum moment will occur under the load that's close to the midspan. So this case, the maximum will occur about here. And if it occur about here, you got to project this. And what you have is this portion of, or this segment of the beam. Okay, will produce the maximum moment for the second case. This is going to be M2, and the load here going to be 160 kilonewton for 4 meter. You get this one for 45 kilonewton. And what we have, the length of this. Oh, anyway, don't forget, you're going to compute this B sub y, and this B sub y will be used here. Okay, and what is going to be this? Okay, you see this is going to be 15 meter, and this is 0.9351, so it's going to be 15 minus 0.9351, and you may get this one for equal to 14.0649 meter, and that's going to be the length here. Okay, and okay, consider the loading pattern 2. Okay, and we may say this is we consider the loading pattern 1 and consider the loading pattern 2. Let me again just take the zoom out, so we have the area to show you how to determine the M2. Okay, do the same thing. I will not put this into this. We're going to use the same one from the free body diagram of the girder AB. Okay, this time we gonna summation of the moment about A. Okay, we do the summation of the moment about A equal to 0. This time B sub y gonna rotate like this, and we have 15 times B sub y, and it's gonna equal to the F sub r, that is 385, and then the distance from the F sub r to A, if you may notice, is going to be the same distance as here. Okay, it's a 15 meter minus this is going to be 14.0649 meter. You just put this one with 14.0649 meter. Now you get the B sub y for this. This is going to be the B sub y going to equal to, this time is 180.5 kilonewton. So this one is going to be 180.5 kilonewton. Then we sum the measure of moment equal to 0 here. Okay, the shear and the 160 kilonewton will produce no moment M2. This one, M2 is here, and the M2 gonna have the same moment at 45. Okay, plus 45 times 4, and it's going to equal to this one, equal to 180.5 times 14.0649 meter, and then we arrive at M2. Is M2 going to be 2,358.7 kilonewton meter. That's a little bit larger than the M pound. So therefore M absolute maximum is 2,358.7 kilonewton meter for this girder. Okay, we get this as our answer of this problem. Okay, this is the end of the demonstration of showing the problem of determining the absolute maximum shear force and the absolute maximum moment. And now you get this one is 2,358.7 for the absolute maximum moment, and this one you get is 319.2 kilonewton. So if this is the case, we obtain what we have by what? By for the absolute maximum shear force. We use the concept of maximum shear force occur at the support of the beam. Okay, it may occur at A or B, but this time we take the B. Okay, so we draw the inference line diagram of the B sub y. We get this, and then we put the loading patterns, actually various loading pattern to the girder. Okay, and in this case we may have 4 of them, and by considering that, we get the result of the maximum shear with the case 1 of 319.7 kilonewton. So the loading pattern is this one. Oh, sorry, we got this one, the second one, 319.2 kilonewton. This one, the blue one. Okay, and then we determine the absolute maximum moment by the concept that the maximum bending moment usually occur in the area near the midspan of the girder. That means it's maybe somewhere here. So we need to consider the loading pattern to determine F sub R, to determine X bar. Okay, and then we consider the loading pattern one, and then we do the calculation. We got 2314.41 kilonewton. Okay, and then we also do the same thing for the loading pattern 2. This time the pink, we got the center line here into the midspan of the beam, and then we get the second maximum bending moment. And since this one is the higher than this one, so this one going to be the absolute maximum moment for this case. Okay, let's you guys have a chance to study it. Okay, you have video clips. When you want to understand, you can rewind and watch it again and again. And if it's possible, I recommend you guys to stop at some point, put the number into your calculator and do it slowly. Try to develop your own skill to solving this kind of problem. Okay, that is the end of this clips.